Okay, so how to find this or how to solve this problem, no? Find the length of one arc of the curve whose parametric equation or x is equals to 2 theta minus 2 sine theta and y is equals to 2 minus 2 cos theta. So since we all know that this problem is, or this given equation is related to cycloid, no? Okay, so in cycloid uh, graph, this is the graph of cycloid. In the cycloid, okay, right here. It contains the x and y. Okay, so according to this, we find the length of the cycloid. This given length of curve, no, of one curve. Okay, so take note that the in cycloid, no, x is equals to a, then where theta minus sine theta. Okay, then y is equals to a 1 minus cosine theta. Okay, so where E here is the radius of rolling circle. Okay, so we assume that we have a circle here. Okay, that is our circle, no? Then again, E is the radius of the rolling circle. Then another is the theta is the angle of rotation. Okay, so as you can see the problem here, that we have the E here is when you say x is equals to 2 theta minus 2 sine theta. Okay, so we have here 2 theta minus sine theta. Okay, then y here is equals to 2 minus 2 cos theta. Okay, or that would be equals to 2 then 1 minus cosine theta. Okay, okay, so again this parametric equation or is all about the cycloid, no? Okay, so again where E here is equals to 2. Okay, so that is our the radius of this rolling circle. Okay, since this theta will where the angle of the rotation, no, from 0 to 360 degrees sa usa lang ka arc, or okay, so for one arc, no. Okay, so therefore when you derive that where dx here where dx that would be equals to 2 minus 2 cosine theta. Okay, derivative of sine is cosine theta, then d theta, no. Okay. Then next, where dy here that it would be equals to the derivative of cosine is negative sine, so that would be equals to positive or negative times negative, that is positive, no, sine d theta. Okay, or dy here 2 sine d theta. Okay, so the formula s is equals to the integral of the square root of 1 then plus quantity of dx over dy squared, no, or quantity squared dx over dy. Okay, then dy here. So the limit is, take note ha, from 0 to 360 ang iyang angle of rotation. Okay, 0 to 360 degrees. So the square root of 1 plus, where dx is 2 minus 2 cos theta over 2 sine theta. Okay. So take note, d theta over d theta is cancel out. So that would be obtained the 2 minus 2 cos theta over 2 sine theta. Then we have the square. Okay. Then dy here, that would be equals to, okay, so we have dy here. So 2 sine theta also here. Okay. 2 sine theta. Then d theta. So we have the integral of 0 to 360 degrees. Then we have the square root. So 1 plus, in this case, we can factor out, no? So 2 times 1 minus cosine theta. So this would be 2 sine theta. Okay. Then square here. Then we have 2 sine theta here. And d theta. Okay. So cancel out 2. Then next, we focus on this, no? Okay, so distribute this 2, no? So mayroon siyang quantity of 1 minus cos theta, then squared over sine. This would be sine squared, no? Theta. So next, let's simplify, let's extract, no, or find equivalent of this 1 minus cosine, or quantity of 1 minus cosine theta squared. So let's multiply by itself. This would be 1, then we have 2 cos theta here. Okay, so cos theta, so cos theta, then over negative, no? So negative cos theta times 1, so negative cos theta. Okay. Then another is negative times negative positive, no? Then or cosine theta times cosine theta, that would be positive cosine squared theta. Okay. So 1, then negative 2 cos theta, add lang na siya. Then we have plus cos squared theta, no? Let us now substitute, or this atong simplify, no? So the integral of 0 to 360 degrees, okay, so 1 plus the 1 minus 2 cos theta plus cosine squared. Okay, cosine squared theta over sine squared theta. Okay. Then we have 2 sine theta, no? Then d theta. So simplify again, no? Okay. So we have here in this case, no, 1 plus that is 1 minus 2 cosine theta, then plus cosine squared theta, no? Okay. Then, okay, let's find the LCD here. Okay. Sorry. Ayan pala yun. Okay. So, by the way, when LCD na to here is sine squared. Okay. Sine squared theta. Okay. So, sine squared divided by this over 1. So, that is sine squared. Okay. So, therefore, this would be sine squared here. Okay. Sine squared theta. Okay. Sine squared divided by sine squared, that is 1, no? Then 1 times kini sa numerator is 1 minus 2 cos theta plus cosine squared theta is ma-remain yun lang yapon siya. Okay. So by the way, take note that the Pythagorean relationship in terms of this, no, sine squared theta then plus cosine squared theta, that would be equals to 1, equate to 1. Okay, so 1 plus 1 minus 2 cos theta, okay, over sine squared to theta, no. By the way, take note how we have the square root again. Okay, then 2 sine d theta, no. Okay, so let's again simplify here. So we have 1 plus 1, that would be equals to 1 plus 1, that is 2, no. Then 2 minus 2 cosine theta here over sine squared theta. Okay, so we have the square root here. Okay, so we have the 2 sine theta, no. Okay, so next we have to factor out 2, no, and then we square out also the sine squared theta. Okay, so we have 2, then 1 minus cosine theta, okay, then over also we have a square root here. Okay, then we have also square root of sine squared theta. Okay, then take natin napala siya ito sine theta. Okay, also sine theta. Okay, then we can now cancel out here the radical symbol in the denominator, no, in terms of sine squared theta. Okay, so we have here a square root of 2, then the square root of or 2 square root of 2, no, we have 2 here. So then we have quantity of 1 minus cosine theta. Okay, then over the sine theta. Okay, then we have sine theta here, so therefore we can now cancel out here, and then we have the integral 0 to 360 degrees to square root of 2, then the integral of the square root of 1 minus cosine theta. Okay, so in the half angle formulas in trigonometric identities, so take note that the square root of 1 minus cosine theta, which is over 2, that would be equals to sine theta over 2. Okay, or that is equals to 1 minus cosine theta, then we have the square root of 1 minus cosine theta over the square root of 2, no. Okay, or is sine theta here, theta over 2. Okay, or we have the square root of 1 minus cosine theta, okay, is equals to the square root of 2, then sine theta over 2. Or let us now substitute now, okay, here. So this would be equals to 2 square root of 2, then we have times square root of 2 here, okay, times square root of 2, then we have the integral of 0 to 360 degrees, okay. Then sine d theta over 2, okay, then d theta. So next we have square root of 2 times square root of 2, that would be 2. So 2 times 2, that would be equals to 4. So 0 to 360 degrees, okay. Then we have sine which is theta over 2, no? Then d theta, okay. So next, let's now, okay, so we can now proceed the integrate on this, no? Okay, so the integral of sine theta over 2, so that would be equals to, where you here, that is equals to theta over 2, no? Okay, so du here, that is equals to integral of what, which is 1/2, okay, so 1/2 d theta, okay. So where d theta here, that would be equals to 2 du, okay, 2 du. Then the integral of sine u, that would be negative cosine, okay. So therefore this is 8 times negative cosine u, okay, then 0 to 360 degrees, negative 8. Then let's now substitute the theta over 2, no, which is cosine theta over 2, okay, 0 to 360 degrees, okay. Then using the fundamental theorem of calculus, so that would be equals to 8, we have the bracket here, cosine, substitute the value of the upper limit, no, which is 360 degrees, 360 degrees over 2, then minus cosine 0 over 2, no, okay. So we can get the open parenthesis and close parenthesis, no. So now calculate using our calculator, okay. So in this case we set the calculator into degree mode, so negative 8, okay. Then we have cosine 360 over 2, then minus cosine 0 over 2, no, okay. So that will be equals to 16, okay. So therefore is the length of curve here, that would be equals to 16 units, okay. So that would be the final answer. So again, this problem given is all about the cycloid, no, okay. So cycloid consists of the angle of rotations, and then the what we call that, the radius of the rolling circle, no, in this case, no, since the problem is length of one arc, okay. So according to this given, no, and then we set into the, or the equivalent of 16 units of length of their one curve, okay. So that's all.